We will be looking at a new variable type, which is the time variable. It has the prefix t# and is in the format of days, hours, minutes, seconds, and milliseconds. For our example, we will use seconds, so to enter a value, just type the number followed by s. The program will convert it to a time variable. In the next section, we will investigate timers. The TON is a timer that provides an on delay. It has a digital input labelled in, a digital output labelled Q. Q is short for quotient, which is a mathematical term meaning result. There is a time input labelled PT, which means preset time. There is a time output labelled ET, which means elapsed time. When the input turns on, the elapsed time will time up until the preset time is reached and the output will switch on. The elapsed time will hold at the preset time. The output will switch off when the input switches off and the elapsed time will go to 0. If the input switches on and off before the preset time is reached, then there is no change to the output. Use the Part 3 file as a template for the next exercise. Place a TON timer on a new section. Use the variables shown and use the exercise 1 operator screen to test the program. The TON timer will provide an on delay. Test the timer operation. Switch on input 1 and leave it on. When does output 1 turn on? What does the elapsed time value do? Switch off input 1. When does output 1 turn off? What does the elapsed time value do? Switch on input 1 and then switch it off a few seconds later. What does the output 1 do? What does the elapsed time do? Draw a timing diagram that shows the operation. The TOF timer is basically the same as the TON timer, excepting it provides an off delay. When the input turns on, the output turns on. When the input turns off, the elapsed time will time up until the preset time is reached and the output will switch off. The elapsed time will hold at the preset time. When the input turns on, the output will turn on and the preset time will go to 0. When the input switches off and on before the preset time is reached, then there is no change to the output. Exchange the TON timer for a TOF timer and use the exercise 1 operator screen to test the program. The TOF timer will provide an off delay. Test the timer operation. Switch on input 1 and leave it on. When does output 1 turn on? What does the elapsed time value do? Switch off input 1 and leave it off. When does output 1 turn off? What does the elapsed time value do? Switch on input 1 and then switch it off. A few seconds later, switch it back on. What does the output 1 do? What does the ET elapsed time value do? Draw a timing diagram that shows the operation. Pulse timer, TP. When the input switches on, the output stays switched on for the preset time and then switches off. The time that the input is on for is not important. The output switches on, then off after the preset time. If the input switches on, the output switches on, the elapsed time will start timing until the preset time is reached and the output will switch off. The elapsed time will go to 0. It is not important how long the input stays on. The output will only stay on for the preset time, even if the input is on for more than the preset time. Exchange the TOF timer for a TP timer and use the Exercise 1 operator screen to test the program. The TP timer will provide an output pulse. Switch on input 1 and then off a second later. What does the output 1 do? What does the elapsed time value do? Switch on input 1 and leave it on for more than 10 seconds. What does output 1 do? What does the elapsed time value do? Now switch off input 1. What does the output do? What does the ET value do? Draw a timing diagram that shows the operation. Modify a start-stop program so that the start button needs to be held for 3 seconds and the output 1 will come on. The insert video will show the action. Use the Exercise 2 screen to test the program. Modify the previous start-stop program so that the output will stay on for 3 seconds when the stop is switched off and then on. The insert video shows the action. Use the Exercise 2 screen to test the program. A free running timer will run for the preset time and then reset itself. The output Q variable is connected to the in via a normally closed contact or inverted input. When the program first starts, the coil free run is off. The normally closed free run contact is on and the timer will start to time up. The program will cycle through repeating the timer rung, checking for the timer to time up. The free run coil will turn on. The program will continue to cycle through. The input of the timer will be off, so the output will be off. The program will continue to cycle through and the timer restarts. The free run coil is only on for one PLC cycle. The elapsed time output has a variable attached and will be a time value that increases from 0 to the preset time, then resets back to 0 and then increases again. That variable can be used as a time base to be used for cyclic timing. Enter the free running timer program into the PLC and run the program. You should see the variable sequence count up from 0 seconds, and when it gets to 20 seconds it should go back to 0 seconds and start counting up again. We want to control two outputs so that output 1 is on between 5 and 10 seconds and output 2 is on between 15 and 20 seconds and then repeats. We can create two sentences. Output 1 is on when sequence is greater than 5 seconds and less than 10 seconds. The comparison functions can be used with time variables providing the time variable is placed on in1 first. Complete the sentence for output 2 and add to the free running timer to control the two outputs. Does the program control the two outputs according to the timing diagram? Modify the program so that it is under the control of a start-stop program. When you push the start button, the two output will cycle continuously. When you push the stop buttons, the outputs will be off and the program will be ready to start again. Test the program using Exercise 2 operator screen. Save the program because we're going to add to it later. There are other variations to a free running program. In this example we have two TON timers which are basically connected into a loop. The advantage of this arrangement is you can vary the on-off ratio by adjusting the timing values of each timer. Enter this program and test it with the Exercise 1 screen. Change the time values of the timers to get a 2-second on and 5-second off duty cycle.